Click start record, and then we're going to go to share the presentation with you, and it should be popping up now. Has it arrived?
Not yet.
It's loading.
It says it's shared, so
Yeah,
I can see it now.
okay, that's great.
Yeah, I've got it.
So we're going to talk a bit today about the urban forest, sustainability of the urban forest, and how we might understand that within the context of a changing climate. So in order to do this, we're going to first of all provide a definition of urban forest, just because there might be others out there that you're more familiar with or you've never even heard of it defined before. It's always important that we all start from the same starting point. We're going to look at why the urban forest is important. Then we're going to look at a sustainability framework. Next, we'll be moving on to understanding how you can get the information to utilise the sustainability framework and therefore assess how sustainable your urban forest might be down there in Plymouth. And certainly using ITree Eco, which is the main method we've been using for this framework, you should actually be able to implement this locally for yourselves. So we'll be looking at canopy assessment and general tree inventory assessment work. And then finally, we're going to be looking at a quick option for you to get involved in a national project of canopy cover assessment, should you desire. So, excuse me. As a group, we utilise this definition for the urban forest, and that is all of the trees in the urban realm. All of those in public and private spaces. They might be along linear pathways or waterways. They might be in amenity areas. It includes those in gardens, for example, as well as those in woodlands. Sorry, I've got myself quite a dry cough today, which is very inconvenient for doing a presentation like this today. Importantly, the urban forest contributes to green infrastructure and the wider urban ecosystem. So it's very much not talking about groups of trees all together that you might think of in the sense of a rural forest. We are talking about the collective of all of the trees across a location. So if you look at various definitions of what a forest might be, they range from 15 or 20% canopy cover for a given area. Well, as many cities and towns in the United Kingdom do attain that canopy cover in amongst all the different land uses, then you can understand why it's quite appropriate to call a city an urban forest if it has sufficient cover. And to think of the trees as a collective body is also a really useful way of understanding how they function and how we can support them to provide more benefits to society. Let's look now at some high-level documentation around recognition of the urban forests and some of the policies around that. Some years back, the UN's Forest and Agriculture Organization did publish some guidelines on urban and peri-urban forestry, and more recently, in amongst the sustainable goals that the UN released, you'll notice there that urban forests are recognised by the UN to contribute to 9 of the 17 sustainable development goals. So actually they're able to reach out and provide benefits in very diverse ways. And if you're not familiar with the sustainable development goals, please do check them out. They're very easily found through Google search. Bringing it closer to home, I'm sure you're all very aware of this statistic, but the Committee on Climate Change suggested that we need to be planting 1.5 billion trees, that's 50 million annually for the next 30 years, or increasing UK woodland cover from the current 13% national average to 17%. But I think what's often not appreciated is that tree canopy cover averages, for England at least, averages at 16% across our towns or cities. And within a city, we know that some cities it can be as high as 45%, or even within a single electoral ward, it could be as high as 80%. The flip side of that actually is that it can also be as low as 0%. Interestingly, currently there is no statutory requirement for a strategy for managing the urban forest, and consequently understanding is rather fragmented and sporadic across the country. So across the three nations, can I just check that the slides are moving on nicely for you? We're now looking at the Scottish Forestry Strategy and the Woodland for Wales Strategy slide.
Yeah, that's
Yeah, mine's working.
Great, thank you for that confirmation. So the Scottish Forestry Strategy does mention urban canopy cover, but in really rather a limited focus. So it talks about using the urban canopy to achieve health and landscape objectives. In Wales, they've developed this more strongly, and they talk about the contribution that these trees make to climate change, to health, to social welfare, to biodiversity, and so on. But again, actually, in comparison to the full range of benefits that we can get from our trees in urban locations, this is actually quite a limited selection. And we're going to be looking more in a minute at the broader range of benefits. But what's particularly useful in the Woodland for Wales strategy is that they do make reference to the use of ITree Eco for quantifying the structure and environmental effects of our urban trees. Closer to home, in England, well, back in 2013, the government's policy statement on trees and woodlands talked about wanting to see more trees and woods in our towns and cities. And again, it then goes on to provide rather a limited or restricted view of the benefits they provide, here stating that they safeguard clean water, help manage flood risk and improve biodiversity. You see quite clearly there's no reference there to some of the social health and wellbeing benefits of trees. And more recently, in 2018, the 25-year environment plan introduced things such as a 1 million urban tree commitment and brought the Tree Champion to us. The document is very much focused on green infrastructure, the environment, providing for biodiversity and access to that. But the references to urban trees and the benefits they provide, again, are more shortly presented. If you're not aware, we are expecting out for consultation later this year England's tree strategy, and that's eagerly awaited. Up in the top right hand corner, you see there some icons representing two documents from the Urban Network on the Forest and Woodlands Advisory Committee, and those documents talk about a vision for sustainable urban forests across England and introducing England's urban forests. They're a couple of years old now, but there's some really useful statistics in there if you're not familiar with the publications. And if you can't find them online, do give me an email and I can drop them over to you. So despite the relative lack of reference to the benefits of urban trees and urban forests at the national level, it is becoming more and more normal within local authorities to wish to undertake an urban forest assessment. And many locations are beginning to have an aspiration for a set canopy cover. I know Plymouth is very active in this and was one of the first to set such a target. And many cities such as Bristol and Manchester, for example, have a one tree per child strategy or target as well. And much of this is due to due to the rise of ITree Eco assessments, and you see on screen some of the icons from some of the publications from those. So, broadly speaking, there are many benefits provided by trees, and this infographic by Tree Economics is a really great way of presenting all of those benefits pictorially on one screen. Although what is missing from such two-dimensional infographics is a recognition that actually tree species and tree groupings are instrumental in the way benefits are provided. So a publication that we released a few years ago now undertook to take a literature review and then a discussion on how various components, as we called it, of the urban forest are responsible for the delivery of the benefits that we've been talking about and that were presented on the previous infographic slide. So for example, the next slide shows a simplified version of some of the information presented in the document I've just listed. So the publication I'm talking about now is the Delivery of Ecosystem Services by Urban Forests, and it's by Davies et al, and it's free to download from the internet. And again, if you can't find it, do give me a shout. So taking some of these benefits in order, the matrix on screen now, like I say, is a simplified version of what you find in that publication, and we've simplified it so it's easier to talk about in presentations such as here. But what the publication recognises or seeks to recognise is that urban forests comprise groups of single trees, lines of trees, tree clusters, as you might find, you know, in say an amenity area or recreation sports pitch where you see 2 or 3 trees clustered together in a corner. And the other component is woodland. And so across each of these different components, we see that the provision of benefits to society are more commonly or less commonly provided. So if we take, for example, here the example of air purification, one tree on its own will take up a little bit of air pollution, but is not the strongest at providing this benefit to society. The benefits are much more commonly and strongly associated with lines of trees and woodlands. I'll just give the one example there. We also did this for excuse me, some of the for a range of the social benefits from trees, and the slide here presents similar information for the health benefits, landscape connections, and so on, and a much wider range is covered in the document itself. We weren't shy in the publication to recognise that trees are also often talked about in a negative sense. They provide what are often called disservices or disbenefits to people. You know, inconvenient scattering of fruit on the pavements, or leaf litter, honeydew from aphids, for example, or just simply blocking our access to light or TV signals. So again, the document talks about how these different disservices are associated with different urban forest components, and this really is there to try and help support our understanding that actually if we're getting comments or criticisms for trees within the context of these disservices, then we can think about actually is there a way that we can change either this, not just the species that's present or remove the tree, but actually can we change the way that the trees are organised and might therefore provide less disservices. So that's our introduction to the urban forest. Where we're going to go now is to look at the sustainability framework. This was presented in a paper we published earlier this year, and the framework is then applied within the paper to a range of cities and towns in the UK's nations. Essentially, we look at canopy cover, size diversity, taxonomic diversity, tree condition, and then a cold hardiness zone suitability index. And we're going to take the first 4 of these now in rotation. So first of all, looking at canopy cover, back in 2017 we published a list of canopy cover for nearly 300 towns and cities in England plus 7 cities of Scotland, and to do this we used the ITree Canopy tool and we compared that to a couple of other assessments. On screen now is a summary of the results that we obtained for Scotland, just because it was easy to put the 7 cities there on one slide, but I've also provided there for you the reference for the publication so that you could see the full range for England and Wales as well if you're interested. And I took from the publication the snippet to show what results we found for Plymouth. So looking at the broader local authority boundary, we identified a 21.4% canopy cover with a standard error of 1.8%. Now, interestingly, within the study, we took a a handful of locations, and we did assessments with different boundaries and using different types of assessment technique. And I've shown on screen here that if we take a different boundary for Plymouth, you get a really quite different result. In this example, 17.4% plus or minus 1.4. And so it's really important to recognise that when you're taking canopy cover assessments and you're making comparisons, that you do always compare like for like, both in terms of methodology and area of interest. You know, it's quite easy to imagine, for example, if you start including more agricultural land on the boundaries of a city, you're going to reduce the canopy cover. Or if your boundary starts extending over woodland, again, perhaps on the boundary of your location, then you can start to bias with an increased canopy cover value. What do we find otherwise across the nation? Well, average in England, 16.4%. The range was 3% up in Fleetwood to 45% in Farnham. So, you know, if you took the 21.4% value for Plymouth that was just mentioned, you know, you're really quite middle of that spectrum, but actually above the mean average. So, you know, it's very good, but still room for improvement. The table on the top left-hand side shows that a summary of the data of the size of the town and the number of towns which had canopy cover within the different bandings. So what we see here is that 175 of all of the towns and cities had canopy cover in the 10 to 20% bracket. So the vast majority fell within that range. But actually, there's no correlation being revealed here of the amount of canopy cover against the size of the town or city. So clearly there are other things at play. So that's our brief introduction to canopy cover and how the value then fits into the sustainability framework. We're now going to move on to the next three indicators that we talked about. To do the assessment within the framework for these indicators, we took data from ITree Eco projects, and so I'll provide you now with a brief introduction to ITree Eco. Eco is just one of the suite of tools within the ITree family. It is recognising that urban trees provide a range of ecosystem service benefits, but this particular tool then goes on to quantify and value those benefits in order to support decision making. What's particularly important to recognise with ITree Eco is it has a focus on the regulatory ecosystem services, and we talked about those in a previous slide. In particular, Eco focuses on climate regulation, air pollution, or removal of pollution from the air, so cleaning of our air, and rainfall interception. Many ITree Eco projects actually are also supplemented with a caveat valuation of the trees to give a feel for some of the cultural benefits of the trees that of the cultural benefits that trees provide to us. The table here on the screen highlights those in red. What we're trying to demonstrate here actually is a recognition that Eco only covers a limited range of the benefits that trees provide to us. And therefore, when we look at the pound values that we get out from ITree Eco, although they're often very, very high, ranging into millions of pounds, they're still actually only representing a subset of the true value of those trees. So what does Eco do? Well, Eco is a field-based assessment. People go out into the location and visit 200 to 250 randomly identified locations and collect a range of information, not just on the trees, but also on the land use, the ground cover, and the condition of those trees. From that, the information is popped into the software and the models are run and the ecosystem services calculated. They're presented on screen. I won't repeat them because we've talked about them already. ITree Eco is quite interesting. I mean, it's just hit its 10th anniversary. The first study was conducted down in Torbay back in 2010, reporting in 2011. For a long time, each ITree Eco project tried to do something slightly new, slightly different, to give itself a unique selling point, perhaps as a better way to provide PR around the project. One of the challenges around this, of course, was it could potentially make it more difficult to make intercity comparisons. But if we just take the raw data, the core outputs from Eco, we can still make the comparisons that we would like to do. Here on screen is a picture of the Eco projects that have been conducted across England and Scotland, Wales to 2017, and it's worth recognising that, as the bar chart previously showed, we're still at really quite modest levels of eco projects per year, maybe just 4 projects per year at the moment. But that does mean that there are well over 20 completed in the United Kingdom now, and so we're gathering really quite a comprehensive data set of the state of our urban forests across the country, from which we can do some valuable analysis. This year I'm actually only aware of one study already underway and one in planning and a couple more in outline preparation stage. So it's probably going to be a bit of a quiet year for ITree Eco this year, as you can well imagine. Let's look at some results then from Eco. Here I've presented summary results from Torbay, Edinburgh, Wrexham and Glasgow. As you would expect, the estimated tree population ranges quite a lot. Wrexham there at 364,000 compared to Glasgow at estimated tree population of 2 million. But of course that boils down quite simply to the size of the city. The bigger the city, the more area, the more potential number of trees you can have. I think what's interesting is that the range in canopy cover at these locations is actually quite comparable, and at 12 to 17% reflects the earlier statistic I was sharing with you of most cities falling within that 10 to 20% bracket. So ITree Eco then allows us to do an analysis of our inventory of trees, and for these locations, we can see that the most common species, time and time again, sycamore is featuring within there. Silver birch features quite commonly as well. And it's also very regular to see hedging trees appear regularly in the most common species, as you would expect here. The cypress and hawthorn, very regular, very common to use hawthorn as a hedge tree in Wales and also around Glasgow. ITree Eco then conducts a further analysis to say, well, actually it's not just about total population of tree for each individual species, but actually what's their contribution to society. So looking at their total leaf area and how leaf area provides different levels of service provision, we can then reorder our ranking of the trees according to their importance with respect to the benefits they're providing. In the case of Torbay, you see it was cypress, ash and then sycamore, but when you consider those in the context of the benefits they're providing, ash jumps to the top. And of course this is a really important way of thinking about our species diversity, because ash is, as you're all aware, with the problems of ash dieback, if you then lose your ash population, you can take a really big hit on the benefits provided to society. Finally, for the table, we can then see, well, what condition are our trees across our urban forest population in that location. And, well, they are 90% excellent in Wrexham and Glasgow. The figure was really quite different in Torbay and Edinburgh, and that's really valuable statistics in terms of how we think about future management. Moving on now to look at the species diversity in a different sense. There's a very well recognised rule that for any species, genus or family, you don't want to exceed 10% of more than any one species, 20% of any genus, or 30% of the family. Now, the analysis that we conducted and presented on screen here shows that for species, all but one location had exceedances across the board for species, genus, and family. And actually, for the second row, the maximum row, you can see that for Edinburgh, for example, there were 12 species. Sorry, there were 2 species that exceeded the 10% rule. That they were actually at 12%. And in Burton, 1 species actually maxed out at 18% of the total population. So you can see this is really diverging from the target of 10%. Interestingly, for all locations, they met the standard for genus and family level population. But actually, some writers have suggested that that rule is far too lenient, and we should be looking at a 5, 10, 15 rule for species, genus, and family, respectively. And this is presented in the second table here. And in this case, the numbers of exceedances across the board are much higher, as you would expect, because it's a stricter rule. Not one single location was able to meet the target for species, and there were many examples of exceedances. So 7 species exceeded the 5% target in Bridgend, for example. And only 1 location, Petersfield, met the target at the family level. So make such comparisons for the size class of our tree. Now, ITree Eco takes measurements of trees for DBH of 7 centimeters and above, so that's diameter at breast height of 7 centimeters and upwards. So in the graph presented here, that's why our bars start, our age category, our size category start at 7 to 20 and then go on to 20 to 40, 40 to 60 and 60 plus. So the last grouping there shows the ideal, which is 40% of trees in the smallest category, 30 in the 20 to 40 category, and then 20 and 10% respectively. Looking across the results, if you look at the first one, Edinburgh, a significantly much higher proportion of the smallest size trees, and as a consequence, all the subsequent size classes deviate quite substantially from the target as presented in the ideal graphs. Did any of the cities match it nicely? Well, Southampton got really quite close, with only the 40 to 60 size category deviating quite significantly from that 20% target. So there's certainly something to be aiming for. We can think of this also in terms of the canopy cover that's achieved versus the density of trees across our location. As you can imagine, if you've got high canopy cover but also a very high density of trees, then it's an indication that many of those trees are within the smallest size category. And ideally, of course, you want to be getting in this top left-hand section of the graph here, of which only Southampton, London and Oldham managed to achieve. So it's very well recognised that size is important when it comes to trees delivering benefits. This next slide presents a tweet shared many years ago actually by the Tree Council, and it's stated that 2 mature trees provide enough oxygen for a family for life. I think it's a great graphic, but as my family is a family of 4, it really relates well to me. But I just think it's also such an important statistic, and I always like to present that. But in terms of quantifying that for the ITree Eco type benefits that we've just been discussing, the figures on the bottom right hand side show us that for a large ash tree, so a large at 80 centimeters dBH, you're getting 200 times more carbon stored than for a tree of just 7 centimeters dBH of the same species. Similarly, we can see that 65 times more air pollution is removed and rainfall intercepted when you compare these 2 different sizes. So that's really quite substantial differences in the provision of trees. If we present that graphically, the figure on the top right hand side presents the benefits provided by trees of large, medium and small stature. So the large stature trees, the curve in blue at the top, the medium stature trees green in the middle, and the small stature trees in orangey brown at the bottom. And the shading around the central line is because we've taken for this study a broad range of large stature trees and modelled the provision that you get. But quite clearly you can see that large stature trees, even given the range of benefits that they're able to provide, way exceed that provided by small and medium stature trees. Moving on, I've mentioned to you that ITree Eco provides pound sign values for the trees. So in terms of annual benefits provided by the urban forests at, again, Torbay, Edinburgh, Wrexham and Glasgow, the trees were valued at providing 1.7 to 4.4 million pounds worth of benefit to the populations of those locations, and storing 5 to 38 million pounds worth of carbon. Now, as I said at the beginning, these are really quite impressive figures. Running into millions, it really is useful to use these and support the case for proper funding for trees. I think what's interesting though is if you start to look at the trees on a tree by tree basis, as we see in the penultimate row here in green font, the trees are providing around £2 to £4 of benefit per tree. Now I think it's worth recognising that this is an average value, and because our populations are highly skewed to the smaller trees, our values are highly skewed to the smaller trees and to the lower values. And if one undertook this analysis for a large tree versus a small tree, you'd probably get tens of pounds worth of value for a large tree versus units of pounds per tree for smaller trees. And that would be an interesting analysis to do locally if you wanted to do a cost-benefit analysis for how much your budget is against the provision of benefit to Plymouth society. This is also exemplified by the cavat value in the final row there. Average cavat values there of, well, 3,200, nearly 3,300 in Wrexham and only 2,000 in Glasgow. If you're a regular user of cavat and understand the valuation system, these are very low values actually, and it's not uncommon to have tens of thousands, 40, 50, 60,000 pounds for a decent size, semi-mature or mature tree. So again, you can see that taking summary values can really skew our understanding. But bringing it all together, how does this fit and what does this tell us about the sustainability of our forest? Well, the slide here uses a red, amber, green approach. Green obviously meaning that the indicator is met, and red meaning that there's a big divergence from the indicated target. And in all cases, for all of the locations assessed, not one city met each of the indicators. Cardiff did very, very well, 4 out of 5 greens, and only red for taxonomic diversity. But places like London, where they actually had a very wide range of species planted, actually still only got 2 greens and 3 ambers. So this sort of simple sustainability framework is a really useful way of thinking about where do we need to target future interventions. We're wrapping up now. Just want to talk to you briefly about an opportunity to undertake canopy cover assessments yourself. I know Plymouth is ahead of many locations in doing this, and you've done it at ward level using national tree map type data. But I thought it's worth talking to you about it because, as we see from the slide here, this is a national project. We are looking to assess canopy cover for each electoral ward across the United Kingdom, with an initial emphasis on urban, but also doing the rural wards. And as there's still quite a few locations in the southwest not completed, and as you might have interest in other locations across the country, and also because we're recording this to share with others, it's good to share this project with you. How do you get involved? Well, the project uses ITree Canopy, one of the tools we talked about much earlier on. We've written a step-by-step guide to take you through the whole process of doing the assessment. But also, one of the initial challenges with ITree Canopy is defining your area of interest. So in this process, in this project, at step 2, we've provided a location, a web map, for you to find the electoral ward that you're interested in, check if it's been assessed already. If it hasn't, you can download the shapefile, which is basically the boundary shape for your electoral ward. You download that, then you visit the ITree Canopy tool, which is an online tool. You upload the shapefile, that defines your area of interest, and then you do your ITree Canopy assessment. Because it's desk-based, it's absolutely ideal for the current, lockdown restrictions. An assessment might take you maybe an hour and a half the first time you do it, as you're getting used to the process and doing the assessment. But once you're in the flow of it, you can easily assess a ward in perhaps as little as 20 to 40 minutes, especially the lower the canopy cover, the quicker it will be. So there's some links there for you to take away. Please check it out, or at least just check out the web map and look at the results that are already being shared online. It's a citizen science project, and our volunteers across the country have already done 40% of the urban wards across the 3 nations. So that's a really good summary. That brings me to the end slide. My slide of thanks to all our partners and collaborators. I'm just going to jump back now to where are we? To Skype. I forgot to click. Oh no, I did click recording, so I can